So in looking at zeros of quadratics, there are three different situations that can arise. One, you can have quadratics that have two real zeros. I say real zeros because later on we'll see not real zeros, but right now, real zeros. It's also possible to have no zeros at all. So if you look at this parabola, it's downward facing and its vertex is below the x-axis. So as it goes down, it's concave down, it goes down, they're never going to touch the x-axis at all. And it's also possible to have exactly 1 0. And that occurs when the vertex of the parabola is actually sitting on the x-axis. So we can have 2 zeros, no zeros at all, or exactly 1 0. Now, one question is, how do you know which of these situations is going to arise? And how you can tell comes from what we call the discriminant. Now, to understand the discriminant, you have to look at the quadratic formula. So we have x equals negative b plus or minus the square root of b squared minus 4ac, all over 2a. Now, the key here is this plus, didn't mean to delete them. The key here is this plus or minus. So we have the negative b, and what we get is our 2 zeros would be negative b plus the square root over 2a, and then negative b minus the square root over 2a. So this plus or minus is where we get this from. So here's the deal. If we have numbers in here, and we take the square root of whatever those numbers are, we're going to get plus that square root, and we're going to get minus that square root. So if there are a real value, a positive value, we're going to have negative b plus that value and negative b minus that value. Now, if this were to be a negative number, we can't take the square root of a negative number. Doesn't have a real solution. And as soon as you have a not real part of this, a complex part of this, this whole thing blows up because we're only working in the real number system. So as soon as you have a negative number in the square root, all of this goes out the window. Now, lastly, the last thing that can happen is if there's a number in here such that it doesn't matter that it's plus or minus this. And the only case where that happens is if what's in the square root is 0, because the square root of 0 is 0, and negative b plus 0 and negative b minus 0 are literally the exact same thing, in which case the plus or minus ceases to matter, and it's just negative b over 2a, or simply one solution. And so the way we talk about this, we're really focused on what's inside the square root sign as well. We focus on what's inside the square root sign, b squared minus 4ac. When b squared minus 4ac is greater than 0, it is a positive number. That's where we're going to get two solutions, because it's going to be negative b plus whatever that square root is and negative b minus whatever that square root is. Now, if b squared minus 4ac is less than 0, so a negative number, we're going to get no solutions. And the reason we get no solutions is because it has complex values, which means it's not any real solutions. The complex value blows it up, and it's not going to be present on our graph. And lastly, b squared minus 4ac, if it is exactly 0, then it doesn't matter that it's plus the square root of 0 or minus the square root of 0. It's the same thing, because plus 0 minus 0 doesn't change our value. And that is the case where we have exactly one solution. So the discriminant, when we look at the discriminant, it allows us to predict with 100% accuracy which of these three cases we're going to get. Is it going to be two real zeros, no zeros, or exactly 1 0? So in something like this, f of x equals x squared minus 6x plus 13, we can use a, b, and c, whatever those values may be for a given quadratic. In this one, it's 1, negative 6, 13. And using those values, we can compute b squared minus 4ac. So for this particular one, that would be negative 6 squared minus 4 times 1 times 13, which would give us let's see, 36 minus 4 times 13 minus 52, which is a value of negative 16. So for this particular quadratic, because b squared minus 4ac is negative 16, that is less than 0. That's this right here, less than 0. I can know with absolute certainty that this quadratic will have exactly 0 zeros. It will have no solutions. It will have no zeros to it.